Hello, I'm Cal Wellborn, acarologist with the Florida Department of Agriculture and Consumer Services, Division of Plant Industry in Gainesville, Florida. We're going to key spider mite to family. Start out, this is at 10x, just generally looking at the mite. Here's leg 1, leg 2. Here's your Gnathosoma. Leg 3, leg 4. And then the prodorsum and your Pistosoma. We're going to go to 40x. Starting out with couplet 1. Idiosoma with 1 to 4 pairs of lateral stigmata posterior to leg 2, cocci-free and movable, without prodorsal trichobothria or podocephalic canals, adults with 4 pairs of legs. Versus without stigmata posterior to leg 2, stigmata absent, located between the glyceryl bases or on the anterior of the prodorsum. Coxa fused into the ventral body wall, prodorsal trichobothria present or absent, podocephalic canals frequently visible on the anterior lateral surface, and adults with 2 to 4 pairs of legs. In lower power, we saw there were 4 pairs of legs. So now we determine where the stigmata are on this mite. This is leg 2. And this is leg 3. So if there were lateral stigmata or paratremes, they'd be right in this region. And looking, there's nothing obvious here. It would look like stigmata or even paratremes. So here's leg 2. I don't see anything there. Always check both sides. This is the leg 2 up here, leg 3 here, and there's no stigmata or paratremes in this region. So we'll look at the prodorsum, or the Gnathosoma actually. We'll look at the Gnathosoma now. Okay, here's the Gnathosoma. You have your palps, subcapitulum, here's the pharynx, and the mouth opening is right there. There's no obvious signs on that, but if we go down here, we see this round structure here. This is the fused glyceryl bases. This is a stylophore. And inside here we have your glyceryl stylets. This is your movable digit. Very long with a recurved base. These are the glyceryl bases that are fused into a stylophore. So it's here where we should look for the stigmata or the paratremes. And if we look right here in the center, here's the stigmata right here. If we focus, see the paratremes coming up, going around and looping right to there, one side, the other side coming up and looping around to here. These are the paratremes. Does not have stigmata posterior to leg 2. Stigmata are present, and since this stylophore is the original glyceryl bases, it's right there between the glyceryl bases at the base of what used to be the glyceryl bases, at the base of the stylophore. Podocephalic canals may or may not be visible. They're not obvious in the specimen. So it's an Acariformes. We move on to couplet 3. Glyceryl rarely chelate, usually reduced fixed digit and modified movable digit. Palps are linear or claw-like, or with a claw-like seat on the palp tibia. Rutella absent. Stigmata openings between the glyceryl bases or on the anterior of the prodorsum, or absent. Paratremes on the dorsal glyceryl bases or on the prodorsum, or absent. Versus glyceryl chelate, palps linear, rutella usually present, and stigmata and paratremes absent. Going back, looking at the stylophore, fused glyceryl bases, we see the modified movable digit, The fixed digit is gone. We have a stigmata right here at the base of the stylophore. We have paratremes coming up onto the anterior part of the prodorsum. If we look at the actual gnathosome itself, we don't see any rutella. And if we look at the palps, here's your palp tarsus, this is your palp tibia. On the palp tibia, there's a claw-like seta, making this a thumb claw. Your tarsus is the thumb, and the tibia has the claw on it. So it's a trombitiformes, prostigmata. We go to couplet 5. 2 pairs of legs versus 3 or 4 pairs of legs. This has 4 pairs of legs. We determined that originally. So we can move on to couplet 8. Couplet 8, pretarsal impodium, legs 1 and 2 with a membranous or nude. Only females with anterolateral stigmatal opening versus pretarsus impodium, legs 2 and 3, claw-like, split distally, pad-like, rayed with tenon hairs or absent. All active instars with stigmatal openings at the base of the gnathosoma or absent. So let's look at the pretarsus of legs 2 and 3. This is leg 2. And we can see one claw with tenon hairs. The other claw is behind the impodium here. The impodium is split distally. There's no tenon hairs on the impodium. Let's look at leg 3. Here you can see one claw. The other claw is right behind there. You can see the tenon hairs coming off the claw. And we're sort of looking right down on the impodium, so you can't tell much about it. If we focus up and down, you can see it's split distally. Let's go to the other side and look at leg 3 on the other side. Might be a better view. All right, here's one claw with tenon hairs. Here's the impodium. And you can just barely see the other claw with tenon hairs on the other side. Let's go back to leg 2. So leg 2, there's one claw right there with tenon hairs. Here's your impodium, and the other claw is right behind it. The pretarsal impodium legs 2 and 3 are not membranous or nude. The impodium is split distally without tenon hairs, and the stigmata openings are between the glyceryl bases or at the base of the stylophore, which is basically between the glyceryl bases. So the stigmatal opening is right there. Here's your stylophore, which is the fused glyceryl bases. So we move on to couplet 9. And here is prodorsal trichobothria present or absent. So we'll move to the prodorsum now. In most of the prostigmata, it's important to know what dorsal seta you're looking at. You need to be able to separate the prodorsal region from the Epistle Soma region of the idiosoma. And in the prostigmata, the prodorsal region will have 3 or 4 pairs of prodorsal setae. So what we're looking for is to distinguish the prodorsum from the opistosoma. And in this view, we can see there's a setal base, there's the other seta, it's pair, there's a seta, there's a setal base, it's pair, and then there's, actually there's one over here. Can't see, here are the eyes. You have 1, 2, 3 pairs of prodorsal setae. 1, 2, 3 pairs of prodorsal setae with the eyes right in here. Now, how do you know that those are the prodorsal setae? The dorsal sagittal furrow, or apodeme, separates the prodorsum from the opistosoma. In most prostigmata, there's some sort of a division. Sometimes it's very obvious, the division through here, and other times you have to look carefully. But in the Tetranychidae, or Tetranychidae for sure, if you look at the prodorsal striations, they make a big U-shaped pattern here. And that tells you, then just below that, they're all transverse. So that division between the U-shaped striations and the transverse striations is the separation between the prodorsum and the opistosoma. That said, we're now looking at the opistosoma. So now we're looking at, starting with the opistosoma, you see the curved striations, U-shaped striations for the prodorsum and there. So this is the first pair of CD in the opistosoma. These are the C1 pair. That's C2. Here's the D1 pair. We're going to move posteriorly. These are the D1 pair. This is the E1 pair. F1, F2. And moving on. Now, this particular specimen is sort of, the posterior end is distorted a little bit, but this is H2. We focus ventrally. We see a pair of CD here. These are the H3s. Here's your adanal CD or PS CD. And if we move around to totally to the ventral side, this convoluted cuticle here is the around the genital opening of the female. And there are two pairs of genital CD, one here, one there. There's the other pair. And then there's one pair of adgenitals here. So in this particular specimen, you have one pair of adgenitals, two pair of genitals, two pair of PSCD, and there's one pair of H's, and there's the other pair of H's. In the Tetranychidae, it's very important to know how many HCD you have. And you can only determine that by eliminating all the other CD. You find the C1, D1, E1, F1. You find your adgenitals. You find your genitals. You find your PSCD. What's left are your HCD. I can't emphasize this enough. It's critical for identifying spider mites. All right, going back to the key. Okay, we need to determine whether they have prodorsal trichobothria. So let's go back. Since we now know where the prodorsum is and where the prodorsal CD are, we can look at them carefully and see if there's any trichobothria. Here's your anterior-most prodorsal trichobothria. There's the second pair, and there's the third pair. These are the verticals, and these two pairs are the scapulars. And all of these are just normal cedal bases. There's no bothridial base. There's no pits associated with these cedal bases. So there are no prodorsal trichobothria. We go to couplet 15. Glyceryl fused to a retractable stylophore, movable glyceryl digit longer than stylophore, recurved basally. Paratremes on anterior margin of prodorsum, pretarsal claws with tinted hairs versus movable glyceryl digit linear, shorter than glyceryl bases. Glyceryl bases completely separate, partially fused, or fused into a non-retractable stylophore capsule. Paratremes on dorsum of stylophore, base of stylophore, or absent. Pretarsal claws usually without tinted hairs. All right, let's look at the first part of it. Let's look at the glyceryl bases. This is the glyceryl base. It's been both glyceryl bases have fused into a single stylophore, and this is the movable digit, very long with a recurved base. Here's your stigmata and paratremes. So to determine whether this is retractile or not, we look at the rest of the gnathosoma, and we can see here's your rest of your gnathosoma with your palps and the gnathosomal base. And we can see that the stylophore is way down here at the bottom of the screen. This tells you the stylophore is retractile. Also, if we look at the length of the movable digit, very long, much longer than the stylophore. Glyceryl bases are fused to a retractile stylophore. The movable digit is longer than the stylophore, recurved basally. And paratremes are on the anterior of the prodorsum here. And pretarsal claws, look at leg 1 here. Pretarsal claws, this is the impodium split distally. This structure here is a claw, and you can see the tendon hairs coming off of it. Other claws behind there, you can see the tendon hairs coming off. So the claws have tendon hairs. The perineum is the anterior margin of the prodorsum. Stylophore is retractile, and the recurve basally. So it matches the Tetranychidae. Now we look at the palps. The palps are either linear or with a claw-like seta on the tibia. Here's your femur, genu, tibia, tarsus, and here's a claw-like seta on the palp tibia. There it is over on the other side. There's your palp tarsus. So they are not linear. They have a claw-like seta on the palp tibia. Go to 17. Palp tarsus leg 1 with 2 short bulbous solenidia versus solenidia linear on tarsus leg 1. The tarsus leg 1, just casually looking, you see there's nothing that's bulbous or short. All the setae appear to be very long. So how do you know which one is a solenidian? If we look right here at this one, we can see that it's lighter in the middle. This tells you it's hollow. Solenidia are hollow. They are chemoreceptors. So this is a solenidian right here. And we can see that it's very long and linear. We go down here, right in here, there's another solenidian. It's also hollow, and it's long and narrow. So the solenidia here are linear, they're long, they're not short and bulbous. Also with these setae, we have what we call a duplex pair. We have a solenidian, and we have a normal seta that's usually very short, and basically almost the same, out of the same base. This is characteristic of the Tetranychidae. Here we have another duplex pair. You can't see the duplex seta very clearly. It's right there. Let's look at the other leg 1. Always look at both sides, because you may get a better view of a character on one side versus the other. And this side gives us a really good view of the duplex pair. Here's the solenidian. You can see it's hollow. And right there you can see the other part of the duplex pair. It's a very short normal seta. If we look down here, here's your solenidian. Here's your short seta on the duplex pair. Moving on to couplet 18. Epistle Soma C row with 5 setae or more. Setae on posterior margin, the 8 setae, are flagelliform or bipectinate, versus C row with no more than 4 pairs of setae. Setae on the posterior margin, non-flagellate or bipectinate. Let's go back to the C row. Here you can see from the striations, the U-shaped striations here, the big U here, this is the prodorsum area, and the more linear, not exactly linear, but closely linear striations here tells you this is the start of the Epistle Soma. So this is the C1 pair, C2, and it's a little distorted here. That one is probably C3. Let's go back to the other side. Yeah, C3 is missing on this side. C1, C2, C3 is right in here, as you see the base. So there's only 3 pairs of C setae. Let's check the H's. We already looked at them, but we'll look at them again. Here are your H's, and just to verify that they're the H's, let's go back. We'll just do the central setae. C1, D1, E1, F1, this is F2, This is H2, and if we focus right here, H3. Normally, if acetyl is missing from the H row in this group, it's H1 that's missing. When H1 is present, it'll look just like, it'll be long and thicker like the other dorsal epistosomal CD. H2 and 3 are usually more similar to ventral CD. So going back to the key, we can see there's only 2 pairs of H's, and they're not long and flagelliform. So we're looking at Tetranychidae. Any questions?